Tony, hi. How are you?
Oh, hi, how are you?
I'm okay. How is the proposal coming along?
I tried to write.
Okay. How far have you gone with the draft? Are you on track to sending through the draft number 1 by Friday?
Yes, we are.
Okay. Nice. And have you been looking at Python? Do you have you installed Jupyter Lab or Jupyter Notebook yet on your machine?
Yes, I have.
Okay, that's good. So you will find, because you're working with 4 other people, what would be beneficial for you guys is to, I mean, of course, when you're working alone, Jupyter Notebook is quite nice because you don't have to worry about the dedicated internet connection. But as you're working on these things as a group, you want to use Google Colab, right? And you want to make sure that everybody is familiar with Google Colab, because it turns out that this pipeline that you're going to be working towards, the implementation itself, is best constructed, at least initially, using a reproducible workflow. You soon discover, I don't know if we get the chance to talk about this during today's session, the different phases of the so-called CRISP DM model. But what you will discover is that when you're actually writing code, right, to build these models and evaluate them, it's a lot easier. In fact, it's advisable to follow through with the specific phases of the model itself. So the entire pipeline, and that pipeline is best constructed using a notebook, essentially. So,
Right.
yeah, I suppose so. As we're waiting for the others, have you got into a stage where you fully understand the project now, or are there still gray areas, things that are?
No, me, I'm sure I'm clear.
Okay. Where are you going to get the data from, if you're clear? What data sources are you going to be working on?
Sorry?
Have you identified the data sources, project data sources? Or you mean you're clear with regard to the high level description of the project, right?
Yeah.
Okay, I see. Nice. I'm not sure if people are going to be joining. It's very strange, actually, that we have no one yet, and this is 1788. I don't know. Have you played around with list comprehension yet, or not? Have you looked at list comprehension? Have you started playing around with the data structures associated with Python? By the way, you will find things like list comprehension quite useful. I like that a lot. I use it very often, right? I think I was showcasing. So the example I was showcasing was a very simplistic example, but let me see if I can get to a notebook for this particular thing here. It's a very powerful, there we go. It's a very powerful feature that I use often myself. But let's see if we can open this up here. Yeah, I use it a lot. I mean, so normally, right, it's a shortcut to, I don't know if you understood what we're talking about, but it's a shortcut to looping, right? So if you're given, let's say you're given a list, right? You're given a list of, let's just call this random examples here, and those scripts. So let's say you have data that you want to process, like it could be defined list of items, for instance. Let's say you have numbers 1 to 10, right? 1 through 10. And I'm trying to see here trying to think of a better way of explaining this, right? Imagine you have a list of numbers, right? 1 through 10, I suppose. and you've been told to say return. Yeah, I'm trying to think of. Okay, we'll make this simple. Right? Just return the squares of these numbers, right? In an ideal case, you would define a list, right? You have the list, and then you'd say you have a list of. In Python, you can use range, by the way. So you can say define a list from 1 through 10, and let me just see here. I keep forgetting about the range thing here. I'm not sure where it starts and where it ends here, but for I'm not sure if it includes 10 here. Maybe it does, maybe it doesn't. List item. So let's say you have a list of items, right? And so it's obviously up to 11 here, right? And you're told to say you should return squares of these numbers. Now, in an ideal case, in normal programming construct, what you would do, right, is you would have to loop through these numbers, and then for each number, you would say, let's say you're told to return another list, right? You would say, define final list or something, right? You'd come up with, you'll have a var final list, right? And then you initialize this to be an empty list or something, or an array, depending on the type of programming language you're using, right? And then in this for loop, what you do is you're saying for each item, you would say you square the item, right? So you would say append to final list. You say append because that's a list, you have an array there. So you'd say append var item times var item or something, right? So you're multiplying var item with itself, and then once you do this, towards the end you return the list, right? In fact, we can just say var final list. So you notice that at the beginning here we have we'll print, or we'll just split out var list, so that when we run this. And I guess I'll just do that, just print it in the next cell here. Now notice that at the beginning this is the thing here. You just say var list is equal to, this was supposed to be a range though. You just call list. Okay, so we will say var initial list as well, var initial list, var initial list dot append var item, so that you have var initial list and yeah, there you go. Right, so this is what you would do, right, under normal circumstances, right? So you essentially what you do is you loop through the numbers, and then you create the list. You start appending elements to the list like so, right? So that you come up with a mutated version of the list which has the squares of the numbers, right? But with list comprehension, what you can do is you can do this just in one line, right? So what you could do is you could say var item times var item, right? And then you say for var item in range 1 to 11. Then you do that, right? So you notice that in cell number 11, actually what you get to do is what you'd otherwise have done in these lines of code here. So I like this feature, especially that when you're working with the sort of data structures that are associated with Python pandas, for instance, you will be working a lot with things like data frames and series, and there's usually operations that you need to perform. And so this is a quicker way of trying to perform that operation, essentially. Trying to see if, so if you've just joined us, we're still trying to wait to see if we can have more people join in here. I'm wondering what's going on. I was almost thinking that Monday, maybe today was a holiday and I didn't know about it because people are not around anyway. So we'll give it until 17:50 and then we can start maybe if people don't join us by then. But meantime, I mean, if people have any questions maybe related to what we were looking at last week, we got to a stage where it was one of those very weird introduction, crash course introduction to Python or something. Yes, please go ahead, Honest. No need to raise your hand.
It's even Doc. So Sis is trying to join, is failing. Maybe can just accept his request to join.
Actually, I don't have to accept. I think this thing is. I thought I configured it to accept by default. Sorry, I didn't. Okay.
Okay.
Yeah.
All right.
Thanks.
All right.
Any thoughts about what we looked at last time? I mean, we were essentially just looking at, it was a crash course introduction to the Python programming language, right? Just enough doors to get you started with Python. And the idea is we would want people to understand the code that is going to be shared. You want to be able to understand what's going on here. So it'd be nice if you could put in a little bit of extra effort so that you understand the syntax at least. Much easier to follow through. I'm trying to see if there's anything else I can latch on here in terms of modules and yeah, I think everything else is. It turns out even when you're using Jupyter Lab, right? As you as we start working with modules or explain about modules, you have to explicitly install them. There are certain modules that don't come bundled with Google Colab, and so you have to run pip install. So I'll show you exactly how to do this. But it's mostly trivial stuff anyway. Yeah, and when you initially get started, what you realize is that most of the built-in functions, most of the built-in functions actually will be sufficient to get you started, because the things that I just printed out here, the things that you have access to by default, right? So you notice that most of the common exceptions, for instance, most of the common exceptions are available to you by default when you're working with files, for instance. We didn't talk about, I don't know if we talked about exceptions, but the idea is really the same as with any normal language, right? So Python will have a try, except, it has a try and except block, right? So you want to, the idea is the same as with any normal language. You want to avoid instances where, let's say you try to open a file that doesn't exist, right? So in this case, let's just say, assume that there's a, let's see if I can find this file here. We assume that there's a file called, just find the file actually. I just want to go into the same directory where I'm running the Jupyter notebook, just so I'm certain here. Let's say we wanted to access this file, right? If you open it in read-only mode, for instance, like so, it will. Sorry about that. It will work, right? Did I open this in the correct? Just check if I'm in the correct directory here. I thought I was. Maybe this thing wants me to use. That would be very strange, right? But I suppose it is strange. Maybe it wants me to use the absolute path or something. So let's say you wanted to access a particular file. This is how you'd normally access a file, right? A file that exists. Am I opening this up in the wrong format here? Okay, I'll just open it without specifying this. All right, so let's say if I wanted to open a file like this is what I would do, right? But assuming this file doesn't exist, you notice that if, let's say, I misspelled this and I said this, I'll get an error that this file doesn't exist. So in Python, I mean, you just, all you need is a try except block, right? So you'd have a try, right? This, and then you say except or something, right? Is it try except, accept, accept? Try except, I think. Catch. Am I forgetting the Pythonic way of accessing this stuff here? We try and see the built-in functions. Let's see here. Yeah, should be casing, right? So you have accept, and then you'd say, maybe you can just say print an error card or something, right? Something of that sort, so that you try and avoid this error here, ideally. But anyway, so this thing, some of these things will probably just pop up as we go along. So it's 1752. I guess we're just going to go ahead and start. We pretty much have most of the people present, at least anyway. All right. If there are no questions about last week, then we continue. I just want us to just quickly, we're doing two things today. I'm not sure if it's going to be really important for us to walk through each of the modules, the core modules we're going to be using. Maybe it will be, maybe not. But eventually we'll transition to lecture series number 3, which ideally is a discussion of the so-called crisp DM model. In fact, that sets the stage for our discussion of the key phases associated with your typical data mining project. So we continue our discussion with part 4, which is core Python libraries. I'm going to skip this part. I wanted us to briefly look at a few data sets we're going to use in the course, but I think we will discuss these during lecture series number 3. So for now, just I'll skip this part. Essentially, what I had planned to do in this particular session was to walk us through the different data sets that will come our way during our discussion of the subsequent modules, right? So you will see me making reference a lot to data sets such as this, for instance. And not to worry, we discussed these in detail soon enough, but I just thought I would just put things into perspective here. So we discuss set is equal to that. So we discuss data sets such as this, right? Let me just say head.t. So we'll discuss this data set. We use this quite a lot. And in fact, one of the reasons why this is used quite a lot is because there's been a few projects that I've done myself, along with some master's students that I'm working with, that heavily make use of data that is structured this way. The other data set that is going to be used often is the ICT 1110 data set. And fortunately for us, we have a group of students. I think I introduced them last week or something. They their final year project is actually is linked to this discussion itself. So what they're working towards is implementing models that are meant to classify or to identify at-risk students or classify at-risk students. So we get to look at these data sets a lot. And the ICT 1110 data set, it turns out, comprises of data from so many different sources. So over the last this is year number 4 now, I've personally been compiling important factors that are linked to a first year course that I teach. And I've developed a particular interest in that course because the failure rate is quite high. So we'll look at this data set quite a lot, but also have things like other information linked to the ICT 1110 data set is student demographics, right? So this is what I mean right here. SEP is equal to, this is what I mean here. So this is, I think this actually, it helps, it really does help a lot in helping people understand data mining, because it's a sort of problem that people can easily relate to, right? But anyways, there's a couple. I've also decided to introduce a few other data sets. There's a few pet projects that I'm working towards myself personally, and I've somewhat developed an interest in trying to look at trying to look at posts, right? Posts that posts associated with popular sites such as Zambian Watchdog, for instance, right? So we'll look at these things as well. You know, I'll describe these data sets as we go along. But so this is why I had this section called data sets. Ideally, these will be shared with everybody once we get to a stage, once we start using data sets. So on with the first library that we're going to heavily make use of is called Matplotlib. So the idea behind Matplotlib is it helps you visualize information. So it's a graphing library ideally, right? I find it quite useful. Before I actually gravitated towards Matplotlib, I used to use R a lot for my graphing needs. So every time I needed to graph something, I would use R. But these days, although I do use R sometimes, but these days I use Matplotlib extensively, and especially when the visualizations I'm performing are linked to some data mining pipeline that I'm working towards, right? That way you don't have to use an external source or an external tool for you to perform crucial activities like so-called EDA, right? So exploratory data analysis activity. And so it turns out that using Matplotlib makes it a lot easier because it's Pythonic in nature, right? So all you have to do is just import it within a Jupyter notebook that you are working with, and then you'll be able to gain access to Matplotlib. So installing it is quite easy, right? Those of you that have installed Anaconda, for instance, will probably have Matplotlib installed by default for you. But if you're like Lighton and you're using Linux, for instance, and you don't have Matplotlib installed, you can install it in 2 different ways. For starters, you can use a pip, right? To install this, so you go pip install Matplotlib, right? And then pip will install Matplotlib for you. Of course, I already have it installed here, so you won't see anything here. The other way of installing this is you can use apt-get actually to install it, right? So Python Matplotlib is how you install it using apt-get. I wouldn't be surprised if you can also use Snap to install it on Linux or on Ubuntu, but that's fine. I do personally recommend using pip. You're probably better off using pip actually. All right, and so testing the installation obviously is quite easy. Remember we discussed how we get to integrate modules into our application. So for you to test if the library that you've installed actually works, you import it, right? So you just issue an import matplotlib, right? And then you'll be able to get this, the output that is shown at the bottom there. So in your Jupyter notebook, for instance, what you would do is, if I can go to the part where we're talking about matplotlib up ahead there, and if we have it here. Right, so what you do is you issue this statement here, right? Import matplotlib, not pyplot, this is. So for you to test this, you would issue and test if matplotlib has been installed. So you just say import matplotlib, right? And then if this works, then you know that it works. Obviously, if this was not installed, let's say if it was a different package with an X at the end, you get a merge not found error, right? Meaning that whatever it is you were doing didn't work. Sometimes you want to check the spelling here, that you are using the correct spelling of the module that you're trying to use. So import matplotlib works. And you can do fancy things here, like use the dir built-in function that I've introduced in the past. So you say dir matplotlib, once you import it, it will show you the different attributes and methods available to you, right? So quite a bit of stuff that is available to you by default here. Something else that you probably want to get into the habit doing is every time you have an entity that you've initialized, you can just type a question mark at the end. This is within Jupyter Notebook, right? Once you press enter here, you get a very nice contextualized pop-up, right? Associated with, it's like the help that you get, associated with the entity, in this case, the merge itself, matplotlib. And you guessed right, what you're seeing here is the doc string, right? So whoever implemented this matplotlib library here created this doc string that you have access to here. Now, what I'm saying here is it won't work if you say, if you come to your interactive console here and you say import matplotlib and then you say matplotlib and then question mark, right? It won't work. This only works in it only works in Jupyter Notebook or Google Colab, right? Or Jupyter Lab actually. But dir works here because it's a built-in function. So you can say dir matplotlib and then you have access to this information here. Something else you can do is if you've installed Zeal, obviously you have access to this help information via Zeal, right? All right. So I don't know if you've installed Matplotlib. Maybe now would be a good time for you to install this so that we can work through, we can actually play around with some of these things as we're interacting so that you're familiar with these things, right? And again, as I'm explaining how these modules work, I won't really talk about everything associated with this particular module, just enough information to get you started. It turns out that a tool like, a library like Matplotlib is quite extensive, right? As you can imagine, you use it to plot the different types of visualizations out there, pie charts, bar plots, right? Line plots, scatter plots, right? But we only look at enough information to get you started. So because we're interested in plotting here, and specifically our interest is going to be with the EDA process, it's important to remind ourselves of the basic structure of your typical plot, right? Now, I don't know if people remember the difference between a plot and a graph here and the chart, right? You probably want to go to Stack Overflow and ask what is the difference between a plot and a chart or a graph or something. It's really different. But your typical plot, right, is composed of certain key elements. A plot will typically have a plot title. In this case, this thing doesn't have a plot title. This thing that I have here doesn't have a plot title, but typically your plot title goes up ahead here, right? It goes somewhere up ahead here. You also have so-called axis labels, right? So this would be like your x-axis labels and your y-axis labels. Usually they'll make comments in formal documentation, say, if you've forgotten to include your labels, include your x-axis labels or y-axis labels, right? So your axis labels. You typically optionally have a legend or something if it's a sort of plot that has different aspects to it, as is the case here. You want people to be able to know what this blue line represents, what this yellow or is it orange line represents, what this green line and red line represents as well. Other things that you have access to that you can modify are things like trivial things, really, like the tick marks here, for instance, and a few other things that will probably pop up as we cover these subsequent topics. Right? But ideally, these are some of the basic elements that comprise your plot, right? So creating a plot is not really a difficult thing in Matplotlib. Assuming you've installed Matplotlib using pip, for instance, the first thing you need to do is you import Matplotlib, obviously. Once you import Matplotlib, you then specify the plot that you want to draw, right? So is it a pie chart? Is it a vertical bar plot? Is it a horizontal bar plot, for instance? Is it a scatter plot? Is it a line plot? And then once you define or you specify the plot, you specify the plot aesthetics. So things like the colors, for instance, that you want to associate with the plot, right? The font face and the font size is associated with the different textual elements of this plot, right? So you can control these different things. You can change the font size and the font face for its axis labels, for instance, if you want to. And then once you're done with the basic plot aesthetics, you render the plot, right? You render the plot. Typically, what you will, I myself, I prefer to be conventional, right? And so most of the things that I do, or the code snippets that I share, are snippets that will be similar to what you find online. So importation of Matplotlib or usage of Matplotlib is done in a certain way, right? You will see this import statement quite often, right? So either you see import matplotlib.pyplot as PLT, right? Or you either see me using this syntax, where I'll say import matplotlib.pyplot as PLT, or you will also see me use something like from matplotlib, right? Import pyplot as PLT. Now, I think we didn't discuss this, but I hope you've come across this and you've read up on what this means, but in case you haven't, I'll explain. This as is nothing more than an alias, right? So the idea behind an alias is when you're importing a particular module, right, from a library, sometimes you might want to access it using a particular shortcut, right? So instead of, because when you import something like from Matplotlib import pyplot, every time you wish to import something from, and I'll run this so that you see what I mean here. Every time you want to access what is available to you via pyplot, you'd have to write pyplot. So you'd have pyplot dot, right? Or something. Need to run this here. So you have pyplot dot, right? Pyplot dot. So the idea behind an alias is, so if I wanted to create a bar plot, for instance, right? I would say, I hope this works here. 1, 2, 3, 4, 5. I hope this works now. So if I wanted to graph this bar plot, this is what I would do, right? So the idea behind an alias is instead of you writing pyplot, use a shortcut. So you could say from matplotlib import pyplot as PLT, right? So that instead of writing pyplot here, I'll just say plot, right? Then this will work as well, so like so, right? So it's just a shortcut, and you'll see me use this in Pandas as well. So when I'm importing Pandas, I'll show you just now. When I say import Pandas, I don't say import Pandas. I'll say import Pandas as PD. So that every time I want to access an entity or an element that's available within Pandas, I'll say PD dot rather than Pandas dot. It's much more expressive that way, I guess. But also, I mean, it helps when you understand this, when you're downloading things or source code from the internet or something, you find that they use this sort of convention, ideally. All right, so you render your plot, right? Quite trivial, really. And so, just to illustrate here, and I'm trying to see if I can illustrate. I hope there's an example here. Ooh. Okay. All right, so you import your Matplotlib, you import from Matplotlib, you import pyplot as plot, and then you start drawing the plot, right? So you can either draw a line plot or a histogram if you want to. It could be a pie chart. So if I wanted here, what I could have done is I could have just said plot dot, instead of thing, I would have said pie, right? Hopefully this works. And then I'll draw a pie chart like so. If I wanted, I could have plotted a horizontal bar plot, right? With the same values on the x and y axis, and then I'll have a flipped bar plot as opposed to a vertical bar plot, right? And then, I mean, the other aesthetic things you can change as you go along. So things like, you know, if you wish to create a stacked bar plot or something that has these bars side by side or something, right? So the key thing here is you draw the plot by specifying the type of plot you want to draw. And to give you an idea, right, some perspective of what you have access to here, what I will do is let me see if I can check out what is available in plot, right, directory. You notice that you have access to quite a number of things here. A 2D line, right? You have polygons, you can draw rectangles. I'm sure you can draw scatter plots somewhere here. We can draw box plots, horizontal bars, vertical bar plot, a couple of interesting things. Some of these things I've not used myself here, but good stuff nonetheless. What else is there? Yeah, so you have your pie chart here. And then by default, there's nothing like line, by the way. A line plot you draw by calling the plot method, right? So this is your line plot here. It's a bit weird here. Maybe we can draw 10, 100, 1,000 or something, and then 10,000. It used to be much better or something. Much better, right? So you draw your line plot by just calling the plot method. Is this a method or a function? I don't know. I tend to interchange this a lot. So it's a function. All right. Yeah, and then you specify the aesthetics, right? So some common aesthetics that you might want to specify here is once you draw this plot here, for instance, like this, you might want to specify the x-axis label, right? X label. So you notice that at this point, this graph, right? This graph we've drawn here does not have y-axis labels and x-axis labels. So I can use the X label function to specify the X-axis label, and I'll just call this, I guess I'll just call this the X axis or something, label, right? And then once you run this, it will appear at the bottom. You do the same thing for the Y-axis label, and then you should be able to hopefully get a desirable output. And again, the other aesthetics that you would come up with would be dependent on how you want this plot to look like. So sometimes it could be that you might want to change the colors, the thickness of this line, for instance. Maybe this is not legible enough or something. You can change the thickness as well. But just to showcase how the output looks like or would look like at the end, and I hope I have an example of a plot somewhere. Maybe not. I was going to showcase something I did in R, but did I do this in Python in R? I can't remember anymore. I don't know. I don't know. I don't know if this was done in, but it doesn't matter. It's just the idea, right? No, I think this was done in Matplotlib, actually, not R. So this is, I mean, so some examples of like a sort of aesthetics you might want. You will notice here that the output you're seeing right now, right, is a bit different from your normal, your default, the default look and feel associated with a plot similar to this. If you notice the background here, the color that I have here is different, right? There's a gray. The background is sort of like grayed out here, and have nice grids that make this whole thing look more visually appealing, right? The font face has been changed somehow, right? I'm using this is a stacked bar plot, right? So you get to change all those things by specifying the aesthetics. If people wish to learn more about how this is done, I guess I can show you. I think the other example plots that we have in here were generated using the same notebook. So you can do fancy things like come up with something similar to this, right? So this would be a faceted, this is called a faceted, it's a faceted grid. So you have information that you have available, but then you present it in such a manner that it's a single plot that has subplots within them, right? So it's faceted in a way. Quite useful, right? If you're working with data that has different types of attributes associated with it, you can come up with interesting plots like this, for instance, right? And the idea really is, it doesn't matter what sort of plot you're using, you're trying to convey a certain message in a certain way, right? And you get to decide how you want to visualize the information. Whether you think that using a side-by-side bar plot is better than using a stacked bar plot is up to you, right? That's the contextual really, right? Anyway, so you notice here in this example, in terms of the aesthetics, the legend is placed at the top right corner, but the legend in one of these plots here, if I can draw attention to this other plot that I have here, it is a bar plot here. The legend here is placed at the bottom right corner. You can choose to place it outside, right? It's common in tools like Excel, I think, where your legend will be somewhere here, right? Or in some instances when I want to have enough space for my graph myself, if I have a graph that has a lot of information, I'll place my legend at the bottom, somewhere here. So all of these things, all these configuration details, you get to change. You get to change as you are changing the aesthetics of the plot, essentially. Right, so quite useful here. Let's see if I can. I was trying to see if I could So some of the aesthetics you can change here. I was trying to see if I can show an illustration using data extracted from, or data that's being manipulated using Python Pandas. Maybe we can do this as an example, I don't know. Some instances, when you were wanting to render a plot, you have to explicitly write plot.show, right? So that you render the plot. This is explicit rendering of the plot ideally. Maybe I can showcase. Maybe I can showcase this before we look at an exercise. I'm wondering if we should do an exercise towards the end right now or something. So let's say you wanted to graph some of this data that I was showcasing here, right? These results here, right? I was just showcasing the one of the data sets just now. Assuming we're doing some exploratory data analysis. This is what I was just showcasing as an example, by the way. But assuming I was doing some exploratory data analysis and I wanted to use, so I have this data, right? I have this data here, which are essentially nothing more than student grades, right? In the different quizzes, quiz 1, 2, 3, all the way test 1. There are 20 quizzes, by the way, here. And I wanted to graph them using a line or something, a line plot, to look at to visualize this information. Because if I was to just give you these I don't even know how many, let me just check how many observations we have in here. But I have 61 records here. Just giving you a table of these 61 records is not going to be very useful for you now, is it, right? You have a student name here. This, by the way, I masked out. Obviously, this is a sensitive, not really sensitive data, but we are very serious about privacy here. But this is actual data, by the way. But assuming you wanted to make sense out of this data, just looking at it, looking at these absolute values is not going to be helpful in any way, right? You might want to visualize it in a certain way, right? Now, how you get to visualize it is up to you, right? You can clearly see that the quizzes are out of 10 here. The tests are probably out of maybe 50 actually. I know it's out of 50 here because we have the 37, we have the 29 here. We can actually get to see these things here by just saying class test 1 or something. Is there a summary function? I think so. No? Okay. There should be a summary function in a data frame though, but I don't know. I was trying to see if we could look at just ICT 1110 grades. Then we will just say var ICT 1110 grades dot. I was trying to see if we could describe, maybe, I don't know if it's describe or, I don't know. Maybe it's describe, I don't know. I wanted to see if we could get, but there we go, right? So you see that the test is actually out of 50 because the maximum value out of the 61 observations here was a 40, right? The minimum was a 0, so someone got a 0 here. Standard deviation and all the good stuff that you have access to. So the point I was trying to drive at here is that just simply looking at this information, right, in its raw form may not be useful at all. So maybe what you might want to do is say, well, maybe I want to plot a bar plot or something, right? And by the way, you can, I think, I don't know if it's a series or something, but probably not. I don't know if it's a data frame or a series. You can actually run. You can plot. You can plot this information, right? directly from a series, or is it a data frame or something? I don't know if this is even useful, by the way, right? Where I'm just, so Python, in this case, Matplotlib just went into the data and kind of plotted a line plot. I don't know if this makes sense or it doesn't make sense. Very strange here. It's just the individual observations, right? I guess it does give you an idea of the sort of trait associated with these data points, right? Like for instance, the maximum value is somewhere around 40. The minimum is right here, right? So these are the individual student observations. We have 60 of them. If you notice 0, they're up to 60. And then these are the scores, right? So the key thing, the thing I was trying to, I don't know if the bar plot here would work even, right? But it requires an additional value here. So this wouldn't work in any way. Bar plot would be a bad idea. But anyways, yeah. Do you think, any thoughts about plotting in Matplotlib? Do you have any specific questions about plotting? Now, herein lies a very interesting thing about most of the things we're going to be doing. A decision would have to be made by yourself on how you want to perform some of these things, right? Like when you're performing your ADA process, well, maybe you're one of those traditional people who prefers Excel. No one is going to stop you from doing that. What you could do is, let's say you wanted to plot these grades, right? So you process your data using Pandas, for instance, and you've come up with this, right? Observe. You've come up with this, you have this data that you want to plot. What you could do is you could, I wonder if we can save here. I think you can write, right? Can't you write here? It should be a way of writing, is it? Write CSV or something. I don't know if it's a data frame, you can to CSV. There we go. So you can send it to list, there should be to CSV, to Excel. Oh my goodness. So you can send it to Excel if you want to, right? I prefer to CSV myself. So I could say to CSV, and I'll just call this, you can also pick on it if you want to, but I'll just call this .csv, right? And then hopefully, if this has worked, it looks like it has worked, I will go to, I'll go in here, right? And then, it's not here actually. I will go to the directory where I'm running my, my Pandas, right? My Jupyter notebook rather. And then I will just, I'll use my preferred tool, right? So let's say you're like Python and you prefer to, it's here actually, you prefer to use Libreoffice Calc, for instance. You can import this data here and then be able to do your analysis from right here, right? So you can do pretty much the same things I was showcasing using a completely different application. But the key thing here is that when you are working from the same application, I think you're much more efficient, in my opinion. I mean, this is debatable, obviously, but I know I would be more efficient, or rather, I am more efficient when I work like that, right? So I could come up with something similar using using a completely different application. But what I've done is I've just exported the data that I would have manipulated, right? I don't know if people have any thoughts about this, just random graphing. I'm wondering if maybe we can pause for a little while and just do two exercises here just to practice our Matplotlib knowledge or something. Any thoughts? Or do you think we can attempt to try out this exercise? Maybe just 10 minutes. I think we should, right? Can we? I will share. I'm about to share it. I'm sharing a data set. I'll share. We'll look at the first one first. And let's try and see if we can do this. So I will share. I'm going to share this data set number one. It's actually already shared. I'll just upload it to. I'll upload it to the shared, I don't know where that is, but I'll just upload it to the CSC 5741 directory, and then I'll be able to share it with everybody else. Okay. So as I'm sharing this, I just wanted to find out if people have any specific questions or thoughts about Matplotlib. Perhaps it's similar to a particular package that you use. I don't know what people have used in the past for graphing. Any specific applications that you've used to graph data or something? Aesthetically pleasing data or something, I don't know. Just share the data set in here. Are you still there, by the way? I'm wondering if I don't know, but yeah, I guess so. Was I reading the CS scores here? Let me just check. So I think I have a number of things open here. What I'm going to do is I'm just going to close some of these things because it's a distraction. I'm trying to check the actual thing I was using here, the actual thing I was importing. Let me just see if I can. And I do believe it's there we go. So it's this thing I'm looking for here. All right, let's see if we can upload it in here. Excellent. So what I've done is I've just shared, I've shared this data, right? So the question is, are we able to, can we plot, or maybe we should wait until we look at Pandas or something, but I'm wondering if maybe people can manage to plot this data here, which is going to be available in the link that I'm going to share in the chat just now. So there's a question, so what's the difference with Seaborn? So Seaborn is just it's a separate package, but you use it alongside Matplotlib actually. It allows you to plot aesthetically pleasing graphs, right? So that you wouldn't actually be able to accomplish using Matplotlib. So the only difference is just a separate package altogether. And what you notice that, thanks for bringing that up. You'll notice that I use it a lot myself when I'm creating, so you can already start playing around with the CSV. I just want to showcase this. I use it a lot when I'm creating, professional plots myself. So I'm just going to look at some stuff we're doing with Robert here, and hopefully, I think this does have Seaborn. We use Seaborn a lot. So if I open this up, what you will notice is that somewhere on top, I'm importing Seaborn, right? And in fact, I do believe Seaborn was used to graph. Yes. So the background, the gray background here is possible because of Seaborn. I'll showcase just now. You can, it's quite, oh my goodness, I think this thing is, it's a separate, there we go. It's a separate package, right? And I want to showcase an example where I get to use Seaborn. So using Seaborn, I can specify the type of colors, for instance, that I want to associate with my plot, right? Notice this is what I do by default, right? So quite useful stuff. Any other thoughts? Do you think we can try out this exercise? Here, exercise 1, where we're saying we plot continuous assessment scores. We draw a horizontal bar plot that shows the grade category for class theory test number 1, right? So by grade category here, we are saying A plus, A, B, B plus, B, and all of the good stuff here. Now what you will notice is that this data, right, is in this form, yeah? By the way, this is a CSV file, but it's pipe separated. So it's in this form. So what we're saying is, can we pull out class theory test number 1, right? Can we pull out this field here? Can we work with class theory test number, where is it? Class theory test number 1. Can we pluck out test theory test number 1 and plot a bar plot that shows us the number of A pluses and B pluses? I don't know if this makes sense. The hint here, in case you're wondering, well, how do we import? We have a starting point here. The way you import, the way you pull out the data is, all you have to do is just say import pandas, and we talk about pandas just now, and then you say pandas dot read CSV, and then you'd say you're reading this. Sorry about that. You're saying you're reading this file that I've shared. You can download it. Then the separator is equal to the pipe symbol, right? Like so. And then this will give you access to, okay, maybe this is the starting point here. This code, line number 2, will give you access to a variable, class test 1, which will only have, it will have a list with class test. Right, so what I've done is I've created code for you with this stuff here. You have a list with class theory test number 1, right? And I'll just wrap this into I'll cast it to a list here. So what I'm saying here is that for you to get started, I've created a code for you, which will give you access to this list of class theory test 1. There are 61 of them. So the question is, can we come up with a graph, right? A horizontal bar plot that will show us the different grade categories. Is this an A or an A plus? Is this an A or an A plus or a B plus or a D or something? Right? The class theory test, by the way, these are out of 50. Do you think we can attempt to do this? Maybe we'll pause for 10 minutes. Is that fine? I don't know if people can still hear me, but can you hear me?
I can hear you.
Okay, great, thanks. So maybe let's just try it out, right? Let's try it out. Let's see if we can just play around with. I've learned in the past, right? I figured this out a long time ago. Quite late in my life, if you ask me, that the more I practice and do things, the better I understand. I don't know if that's the case for you, but one of the reasons I always push us to just try them out is because sitting and just listening to someone, watching someone do something is probably one of the easiest things you do, right? But if you just try and write these lines of code here, it might help in kind of accelerating the rate at which you are picking up most of these things here. So maybe let's start by downloading. We will download this data set to your local machine. So you can download it to your local machine and then import pandas, and then try and just copy and paste this code here. Alternatively, because this has been shared with everybody else, you can use Google Colab, right? You can use Google Colab and be able to access this, I guess. Or you can download this file and then import it into your drive and then try and read it into your drive via Google Colab. So let's say we reconvene, maybe we let people just work on this and try and see if they'll be able to do this. Then alternatively, right, if you think importing is a bit tedious, here's an option for us. What if we just copy paste it from the chart what Lighton has done is he has, oh, you're using a phone. Oh, I mean, I can use my phone as well, right? I don't know if you've played around with tools like what do you call this? Temax. I use Temax myself. So, Mike, using your phone is not an excuse these days, unless if you change your mind and you tell us that you are using a feature phone, a Huawei feature phone, ZE feature phone. But maybe what we can do, right, is we can, I've pasted the list here. Maybe you can work with the list. So just copy the list and then try and see if you can graph this. Use that as a list. So just create a variable and feed it this value to be a list. So you copy this and then you say pi3 and then you say var ICT 1110 list is equal to this, right? So I have access to var ICT 1110, this list here, and then I can work with this list, right? Maybe that's better. If using Python pandas is a bit intimidating for now because we haven't yet gotten to that stage, maybe we can use this as a list, and then let's try and see if we can graph that question. Now, I should tell Mike here that you can, I don't know if people have used this before, but I use this tool quite a lot myself, and I can use a tool like Temax, right, and be able to program. There's no excuse here. I think I have Python installed here as well. No, but I can install it, pkg. I thought I had Python installed though. Pkg, sorry about that, pkg install Python. If you haven't looked into Temax, you might want to install Temax, quite useful, right? You know, when you're on holiday somewhere and you didn't carry your phone, maybe your spouse said that don't carry your phone, no work here, but you can go with your phone and then you have Temax and you can write code or something. But anyway, so maybe we can use this input, the list, and then we can work through this this example. How does that sound? So 10 minutes, maybe we'll convene at 10:50, right? We're working through this question here. 1A and 1B. We'll pause for a while. If you have a question, I'm still here. You can interrupt me and then seek clarification or something. But maybe let's try and see if we can get our hands dirty. That we understand this. And I'll just have Temax for the benefit of Mike, I guess. I'll have Temax on the other side here so that and as well working on this, I'm eager to hear people's thoughts about Matplotlib, if it's perhaps related to some graphing software or package that you've used in the past. Usually, right, most of these applications that people use point and click, right, like Excel. Maybe all you have to do is, the only hard work you have to do is maybe you pivot the data, you summarize it in a certain way, and then you just point and click, you choose the sort of visualization you want. That works also, but when you're handling large data sets, which is the case when you're working on data mining projects, right, you won't be working with 61 observations. You're working with millions of records, gigabytes of data. And those of you that have worked with large data sets will agree with me that at some stage, right, Excel just simply fails. Right now, sure, I mean, some applications like Google Sheets might be able to scale up to a certain point in time, but you want to use a tool like Pandas so that you are handling gigabyte-sized data, right? And we have been doing this ourselves. As we are working on this, maybe I can showcase something we've been doing, I think. And this is obviously nothing compared to what some of you do at work, like the banking sector. I know handles quite a bit of data here, but just to give you an idea, right, of the type of data sets we are handling here. There's something we are working towards here. If you look at this, this is 792 megabytes of data, right? Good luck loading this in Excel. Try it, I dare you, right? But with Python, right? With Pandas, of course, in this case, we don't necessarily use Pandas per se, but we use. I like using a package called Dask, right? It's meant for parallel processing, so it makes it a lot easier for you to handle large-scale data, essentially. But I'm eager to hear people's thoughts about, as you are working on this exercise, other graphing packages that you've used maybe in the past. Or none. Oh, wow, I didn't know this is... Oh, you know what? I didn't know that... this is interesting. I had no idea that when I use... I'm discussing this. When I use SCRC Pi, right? I can use, when I contextualize my phone, right? I can, I don't know what that is. I can actually use my keyboard, right? So I now have, I'm using my keyboard. Oh, this is nice. I'm using my keyboard on my phone, and I can do, if I was Mike, I could actually run Python code on my phone, right? So I'd say, you know, what's this for? Yeah, I can do that. var I times var I something. All right. It appears there's no thoughts about. I can probably also. I don't know if I can graph here though. Import. I don't have pandas, obviously, right? I don't know if I even have pip installed here, but Matplotlib, I'm reaching here. Nothing. Okay, that's sad. Nothing. Okay, that's okay. Pip. Okay. Oh, I already have pip installed. Matplotlib. I hope this will work. I don't know. It does work then, it appears. This is good. Turning my phone into my computer now, I suppose. If there's someone who has gotten somewhere with the graphing, with exercise 1A, maybe in the next 2 minutes you can, or 4 minutes you can show us what you've done, perhaps, I don't know. Maybe not. So. And I don't know if that sound made. Okay, I will forget. I hope we managed to allow Roy in. Is Roy in the house? You see, I just saw this.
Yes, I've managed to get in now.
Oh, thank you very much. Sorry, I just saw this message here. Now, one of the things I've been wanting to do is one of these exercises. Maybe we can do. There are these groups that I'm a part of, right? And I should showcase this to you. I don't know if it's there somewhere. Maybe it's not. but there's some of these groups that I'm a part of. Like if you see this thing that says unser Dons Social or something, I don't know. This thing, right? I've even muted it because there are a lot of, number one, you have a lot of people that are part of this, the 251 participants. Now, if you look at the content in here, for me, some of the content is spam, right? And which is why I've muted this thing. But we can use machine learning, right, to identify posts perhaps that one would find useful or something. I don't know. Maybe we can use this as an example at some stage. So my installation is clearly taking quite a bit of time here, if you notice, because I guess this is, I've even forgotten what it is I'm installing here, but it's one of those large packages, I hope. I'm guessing. I don't know if this was Matplotlib. But has anyone managed to work on this? Like graphing this? So using the data set we just shared, or the list I just shared, can we draw a horizontal bar plot that shows the grading categories? In fact, this is just nothing more than an extension from last week, right? So the grading categories from which are here. I assumed you had this. You have these grading categories, and then you just plot. You plot the grade against the number, right? So if this was a bar plot, what would be grading, right? Is some bar plot that showcases that shows us that I'm trying to. There we go. So it shows us that maybe A pluses, usually there are a few. It goes up to here. A, just have a few here. It's bell curve, right? A is here, and then maybe B pluses somewhere here or something. That's the bell curve actually. It's like here. Maybe you have quite a number of B's or something, and then you have your C plus, C's. Very few people tend to fail here, right? D's, and it's untrainable or something. And then you have quite a few here, maybe somewhere here or something. So this is what we were hoping would, this is what we're trying to come up with, right? Typically we expect a few to fail here. Well, that's not the case for this course, but that's fine. Has anyone come up with this yet? Or not yet? Is there anyone who wants to share what they have, or not yet? Yeah, so, I mean, so the first point, the first thing one would do here is just to, you can either, and in fact, we can make use of the same code we had last week to cut down on the amount of time here. And I do believe I had it here, so I'll just load it using the load magic, and then I will say I will ideally want to come up with this, right? This thing will show you, if I run this, which I have, this function fx postgrad will give you an output with the grade, the description, and everything else. So you can come here, and then you could say, this is the test of thing here, right? You could come here and then you could say, what happens when we check, unless if there's someone who wants to show us the stuff, no? What they have. We'll start with the first observation, which is 0. You notice that this will give us, it's a D, apparently, according to this. And this is wrong, actually, because the grades are, all of these will be D's, actually, because the grades are in raw form, and this function accepts a percentage, right, if you remember. So what we would do is we would just multiply this by 2, right? So we know that, this is weird. What is 0? Let's check out 0. What is the value 0? 20. Oh, yeah, so it's a D, it's 40, right? Times 2. It's a 40. Let's look at a value that has, this is bad, right? Beautiful. So if we look at 10, for instance, 10, list item 10 is a C++. So what we want is we want to convert our list into this thing here. Now, we could do this in different ways. We can loop through our class test1 list, right? And then just create a completely new list, right? Which I guess would be desirable. So we'll say var class test1 grades, and then we'll just say this is equal to an empty list, and then we'll loop through, right? So for var, we'll just call this grade, I guess. Because this is iterable, we can iterate through this, or iterate through the this class theory test 1, right? Which is what you copy pasted from the chat window there, if you remember. And then we will, as we are iterating through this, we will say we wish to get, and maybe this will make sense if I do this, sorry. We wish to get, our comment is to showcase what we want here. What we want is not to get this tuple with all the 3 items in here. Rather, what we are interested in getting is just the first item, list item 0, yeah? So the grade. So in effect, what we're building here is nothing more than a new list. There are different ways of doing this, but we're building a new list that will comprise of just these grades. Observe. So we're saying we will call this function, right? fxn postgrad, right? And then we will feed it the value here, the grade, because we're looking through our list. We'll feed it the grade times 2, right? And then we want to get list item
should get the
0,
same put here.
right?
You should stop doing like
So
this. That's why it's penny. When
we
it
get
gets code, that's what happens.
we get list item 0, and then once we do this, in fact, what you can do this, right? You can
do that.
kind of overload
Get
things
the
in.
same.
You can just say we are going to append to this list item. We will append the new value, dot append, yeah? Now there's different ways of doing this. I'm just showcasing what I would do myself, which is what I'm doing right now, I suppose, I don't know. So that eventually we end up with these grades here that we want to graph. And to kind of, I think to make this a lot easier, what I would do is I'll just create a new cell right below here and just say, when I run this, what I want is to come up with this. And this is what we want to graph. We are graphing grades, right? I don't know if this is making sense. Now, also, I mean, so there's a couple of different ways of looking at this. Let's see if we can graph, because we get categories, let's see if we can graph this, right? PLT dot bar, horizontal. Now, because the horizontal bar plot expects 2 things, right? It's X and Y. So this is interesting, actually. Because this expects X and Y, what we could do is we can actually look through this again, the grades. And we are making this redundant because I'm trying to see if we can combine different things here. What I'm saying is that if you look at the list we have now with just the grades, we can't graph a bar plot because a bar plot requires an X and a Y. In this case, our X is supposed to be, our X-axis, because it's flipped over, our X-axis is supposed to be the count. And then our X-axis is supposed to be the count, and then our Y-axis is supposed to be the grade. So if we are to come up with something like this here, we need to have two separate lists, right? One which will have, we need a grade and a corresponding count, essentially. So all we have to do here is, again, maybe loop through the grades, right? So we'll loop through these grades, and then we'll say, maybe I should have created the solutions beforehand, we're wasting time, but that's fine also. We'll loop through these grades. This is I'll call this plot input or something. For input, var plot input. in here. Now, the interesting thing here is because we need two values, what we can do is we can either create an X for two separate lists for var X input and var Y input, so that we have this value separately, and this will make sense soon, hopefully. And then as we are looping through our grades, we would say, this is interesting. We would say, I don't know if people remember this, right? The functions we have in lists. If you remember, we have this, right? Count. We can count these, right? This course. We can count D pluses. There's something wrong here. We can count B's. This is the problem I was talking about. We can count A's, right? So if we can count, then what we can do, right, is we can say, if we can count, then we can say, as we are looping through, because we'd have to loop through the unique values actually. We could say, in fact, we don't have to loop actually. We could just say, we've gone through it right here. We could say var Y input is equal to, we'll follow the order of A plus A, sorry about that, B plus B, C plus C, sorry about that, D plus D, right? And then we will say for var X, right? We will say, we'll start appending. This is very strange. We will start appending for var A value, var X in var Y input, right? We're going to just say, we're going to say in here dot count. We are counting, we'll call this var Y actually. We are counting how many items there are in here that are equal to 1. Once we count these, we append them to our list, which is var X input dot append. And this is a bit confusing. I just want us to get to a stage where we actually have the result really. I mean, you can look at this code, this messy code later on. I'll share this. It's really messy actually. And maybe I'll clean it up later on. But ultimately what you want, right, is you want this, right? You want to know how many A pluses, how many A's you have, how many A pluses you have, how many D's you have, how many D pluses you have. So we have a mapping now. We have our X and the Y here, if you've noticed. So run this Y and X. So what we're saying here is that no A pluses, 2 A's, 0 B pluses, 1 B, 5 C pluses, 2 C's, 0 D pluses, 51 D's. This is actually the motivation why we are trying to work towards this problem, by the way. I introduced the group of 4th years that are joining us in this course. They are working on this problem. They're trying to see if they can build a model that's going to help address this problem, high failure rates, right? But anyway, now that we have this input here, what we can do is we can say, well, we are going to plot this, right? So say this is a horizontal bar plot, and all we do is we just feed it the X and the Y. Now, X and Y is here, a bit of trial and error here, but this is what we want, essentially. And then we can do the aesthetics, and this is weird. Very strange, right? Very sad. But that's, where is this 50 coming from? There's something wrong here. This isn't supposed to be a 50. Where is the 50 coming from, I wonder? Let's see here. Oh, so it's, I don't know if we've, maybe it's because we've switched them around. It's supposed to be the other way around. So it's y against x, because this is a horizontal bar plot, right? But it does look like a bar plot, but you want it to be like this, yeah? Essentially, this is what you'd come up with. Now, the thinking here is that you are using Matplotlib to be able to visualize information this way, because by looking at information from a visual perspective, it turns out that you're able to make sense out of it much, much better than you would if you had access to the raw data like this, right? This is not useful at all, in essence. Any thoughts? I know, sorry if this was a bit, it's all over the place, but I'm just trying to showcase an example of how you would come up with this visualization. Now, you could have done this differently, I guess, I don't know. Any thoughts so far? You will soon see with Pandas, right, that some of these things can actually be done in just a few lines of code. Because with Pandas, you can pivot data, right? You can pivot data. Once you pivot that data, you can graph the data. You can group data, right? I'll showcase to you. Look at this. If you have this class test, right? Instead of doing what I was doing here, where I'm looping all over the place and I have messy code in so many different cells, and then finally I graph this, what I could have done, right, is I could have come here and said, well, I have this Pandas data frame, right? Oh, it's a list. Oh, I converted it into a list. I wanted to convert it into, I wanted it direct into a data frame to avoid it being messy. So what I'll do is I'll just create another thing here so that it's actually a Pandas data frame. I converted it into a list up there on top. But what you could do is you could say, create, I'll call this class series test 2 here. But this time around, I won't convert it into a list. So that if I check this type, this is a series. I think the series will do. I'll convert it into data frame like so. Sorry about that. Sorry about that. Like so. Right. So what I could do is I could say I can work with this data frame now, right? So instead of what I was doing here, where I was doing things all over the place, what I could do is I could say, well, what I'm going to do is I'm going to group this information, right? I'll group by. So I can group this by, I wonder if I can, or if I had the grades, I guess, I could have grouped them by, I wish I could showcase this, but look at Pandas, this group by function is quite useful. You can summarize the data, right? So I don't know if we can group these by test or something. I'm wondering what, maybe we can count, I don't know. I'm all over the place, but I wanted to showcase you could easily group this information, and then once you group it, you plot it by the group by variable. So what I'm essentially trying to say here is that with packages such as Pandas, you can cut down on the steps if you feel that going through the traditional Pythonic way of looping through a set of values and then aggregating them. If you notice, we looped twice, right? You can have one-liners where within Pandas you can actually make use of these things. You can actually even pivot data, right? But anyway, let's not forget why we're doing this. I was just showcasing. We were working through this example on how we can graph this information, an exercise to help us get started with Matplotlib. I want to ask that maybe at your own time, please find time to go through question number 2 as well. It's in the notebook that I shared. I also share this updated notebook in the event that someone wants to salvage the messy code we have here. I don't know if it's going to be useful in any way. But I also had another example of basic needs basket here. I don't want us to waste time, but I just want to, it'll be a fun way of you trying to, gain access to this information, right? I hope this thing is still working. I hope the basic needs basket. Okay, that's a bummer. I hope the basic needs basket is still there. Okay, I'm gone there. What I can do is I'll change this link to, I don't know if just here I was working on, we can look at the most recent one. It's controversial, right? With the elections, they're saying the basic needs basket in Osaka has gone up to 8,000 now. It's quite a bit there. But I don't know if people have been following this. I just want to point you to a link, the up-to-date basic needs basket, so that BNB, so that you have a better 21. You have a better reference point or something. I don't know. I can't find the. This is the thing. I think they've been making changes to this site of theirs. Not very helpful at all. I thought I had it somewhere though. I saw it somewhere. That's okay. I thought I'd downloaded it, but any thoughts as we as I'm looking for this update BNB? No thoughts. JCTR basic needs basket. That's okay. I think I should have, I hope I don't have it here as well. I will look for this and then I will share it. I thought I had it somewhere. Yeah, I don't know what's happening here. I thought, I was hoping we could look at the most recent one. I have the 20, it looks like I have this document here. I'll share it in the dataset link here. So this is wrong. It should be the Lusaka BNB, which is this one. Right, so the idea is, can we work through this example by looking at something like this, right? So we'll be able to graph, information to do with how much it costs a family of 4, I think it is here. So they assume a family with 2 kids and wife and husband or something. And, them buying things that will ultimately result into like a balanced diet or something, and they take into account things like school fees and whatnot. It's crazy what's happening. Not too long ago it was at 5,000, but now it's 8,000, right? But anyways, if there are no thoughts, then maybe we can, so update this notebook with the correct link. I will upload that thing there in the thing. We can continue our conversation with the remaining libraries, right? Hopefully this Matplot example gives you an idea, a sneak preview of how you get to use Matplotlib, right? Maybe just quickly we can look at Pandas, like just a gentle introduction to Pandas. Very, very useful way of analyzing data in Python. Probably one of the most widely used data analysis packages or libraries in Python, actually. In fact, it's used hand in hand with machine learning libraries and deep learning libraries. So things like scikit-learn and Keras, for instance, would tend to heavily rely on Pandas. So if you're looking for motivation for why you might want to use a package like Pandas, I think I already gave it away. Efficiency, right? You won't have to worry about your data, your machine hanging as your Excel is trying to process whatever information you're working with. And this is usually for information that scales beyond maybe 1 million records or something, right? You're bound to face these problems. In fact, I've experienced these problems myself for data sets that are less than 1,000 actually, right? I guess it's in part linked to how much memory resources you have. But the other reason why you might want to use Pandas is it's actually very user-friendly, right? It's quite intuitive. So the design, I imagine, took into account one of the most widely used data analysis packages, is spreadsheet application. So you will notice that data is represented in a dimensional space that's somewhat similar to your Microsoft Excel, Google Sheets, or LibreOffice Calc, right? So it has a familiar feel to it, if you will, right? So in essence, your Pandas, the main entity Pandas entity you're going to work with is a so-called data frame, right? This is where you start from. It's a starting point when you're importing data. And it's nothing more than a two-dimensional labeled data structure, right? So you notice that the data structure is similar to your Excel, right, or a spreadsheet application, where you have your columns, right, and you have your rows. Yeah. So quite similar. This is what you see there. The other data set that you will find yourself extensively working on is a so-called Pandas series. So this is nothing more than just a one-dimensional labeled array that can hold different types of data sets. A nice way of thinking about a Pandas series is an extract of one of the columns, right? So if we wanted to extract values associated with student IDs here, we would end up with a Pandas series. Right? If we wanted to just extract gender information, we'd come up with a Pandas series. So this is what I mean here. I'm just going to go down here to showcase this information here, and I will actually import, just create a thing on top here, and I want us to make use of the same data we had up on top here, which is class. I'll use this as an example, and I'll call this class 3 or something. So what I mean is, if you imported data like this, right, from a CSV file, and you wanted to pull everything from here, this is what you would do, right? And I explain more about this class test here. So you first of all end up with a so-called data frame, right? So this would be your data frame. var class test 3 is your data frame, right? Your data frame is composed of rows and columns essentially, right? But if you extracted, right, a particular column, information associated with a particular column. In this case, let's say we wanted to get student names, for instance, right? So it's a student name. What we end up with, right, if I check the type here, is a series, right? A Pandas series. So just a one-dimensional labeled array in this case. And it's nothing, it's just similar to a column in a spreadsheet application. Nice way of thinking about a series, it's a column or column values. A nice way of thinking about a Pandas data frame is it's nothing more than your worksheet, right? So when you create that file in Excel, you have apparently a workbook, right? Within a workbook, you can have multiple worksheets, right? A worksheet is composed of a two-dimensional labeled data set, rows and columns, right? So if you have something similar to this, what I've opened, this file is my workbook apparently, and then a workbook has multiple worksheets. I can have multiple worksheets. So our Pandas data frame is similar to this worksheet here. A series is similar to this column here, right? So we'll have a series called quiz 2, a series called quiz 1, a series called student name. And really, in essence, working with Pandas involves just plugging these different values, right? If most of this is not yet making sense, don't worry, it will make sense eventually. Some other weird things that they'll be strange at the beginning that you'll see is things like ellipses, because of the fact that sometimes your data set will be quite large. You might have thousands, millions of records actually. Pandas has a way of trying to just show you just sufficient information to give you an idea of what the data is about. So you see a lot of ellipses, right? So these things here, right? These dots, these 3 dots, what this tells you is that there's more information in between. So Pandas only selectively shows you what is relevant, right? Both on the column side and on the row side. So you notice that the columns, you only go up to quiz 7, and then you have this ellipse, right? Same for the rows here. But at the bottom, obviously, Pandas will show you that what you're working with is a data frame that has 61 rows and 27 columns, right? In essence. So be wary of the ellipses there. And then also there's automated indexing. So your data is automatically indexed for you, irrespective of whether you might have a column that has unique values. So in the case of what you're looking at here, and by the way, in case you're wondering, maybe we can map the scores that we have, the anonymized scores. This is a different data set. So good luck with that. But that's fine. I think I should have anonymized this as well. But Pandas automatically indexes your data, right, from 0. But what you can do is there's ways of changing the index so that it points to your preferred index. So in this case, I could easily change my index to be associated with the student ID, because I know that for this particular use case, a student ID at the University of Zambia is unique, and in fact, an email address is unique. And I know, I mean, it could be the case that you might have duplicate data. Maybe that could be a bit of an issue here, but this is a decision you have to make anyway. There are some interesting functions that you will see me using. In fact, you will see these as you are working with Pandas, as you are looking up tutorials online. So there are interesting functions like ilog function, right? Which you essentially use it to access a particular value that you want. So if I wanted to access a value at index 100, the question is, how would I access this if I have a data frame, right? Class theory test 3. Well, I can use ilog, right? I can use ilog to say I want to access the value at index 100. So I'll just say ilog, and then I'll say 100. And then I have access to, by the way, I'm getting an error here because my data frame only has 61 rows, right? Index error. So I could just say I want to access this at index 50, like so. And then I'll have access to just this one. And I don't know if people already know what this type is. Series, right? I have access to this one data set of a student, right? So this would be the record. I've accessed one record, right? With the student ID, the name, these are all mass details, and the quiz values that the student got essentially, all the way up to the end here. It's quite useful. And so some random functions that you can use also. Can I use this? I guess I can't. I don't know. I can transpose this. That's fine. So pretty useful function ilog. Right? So a way of uniquely you use the ilog to get the index location, specified index location. I could use ilog 0, right, and then get the first element. If we have 61 items, I know I don't have 60 because numbering starts. I don't have 61 because numbering starts at 0, so it's all the way up to length -1, right? So this is the last item. I don't know if your actual index -1 would work here to get it does actually. You can also use the same normal indexes, right? So the normal index rules apply here. If you remember, if you want to get an index that is at the last entry, instead of saying length -1, you can just say -1, right? So you get the last item. So this works for ilog as well. And then your data obviously is what you're seeing in that red bounding box, right? So everything excluding the automatically generated indexes and the column names will comprise the data essentially. There are some really common operations. There are actually a number of operations that you have access to, the ones that you're going to find useful is the operations that you use to read data from external sources. So if you're working with a CSV file, there's a function that you use, right? is it a method or something, that you use to read a CSV file. There are methods that you use to read JSON files. There are methods that you use to read HTML files. There are methods that allow you to run SQL queries, right? And I remember Derek had asked this issue of how do you read data from a database, and I thought I would include a few examples about how you go about reading data from a database. But it turns out that you just go through the same series of steps, right? You identify a library that is specific to the database management system. So if you're working with MySQL, for instance, you need a library that's going to enable you access data in a MySQL database, and then you can import using read SQL, right? So if you import pandas as PD, you can, when you say read, these are the things you have access to. You can read a CSV file, you can read direct from an Excel file, which is quite useful. If you work with SPSS, right, you can read directly from an SPSS dataset. I've worked with people before that were working with SPSS datasets, and this was a lifesaver, right? You can issue an SQL statement. I have a few examples here. An SQL query, for instance. You can read data in tabular form, right? You can read data from a clipboard. I do believe there's ways that there are other ways, there are other, I guess, methods that people have probably come up with. CSV. Let's type this. That allow you to extend this, right? So the other functions, I wouldn't be surprised if people have come up with additional functions that will allow you to read data from other alternative sources. So, in as much as we cannot really sit here and talk about all the different functions that you have access to in Pandas, the point I'm trying to drive at here is that there are some useful operations that will come in handy as we are going through this course here, as we cover subsequent modules. Of particular interest are going to be functions that you use to read external data sources, but also operations that allow you to inspect data frames and manipulate data frames, right? So common functions that will allow you to inspect data frames is you can take a peek at the first couple of records of a data frame. So you use the head command. And for those of you that are familiar with Linux, you will remember that most of these functions actually are a direct mirror of what you use in Bash, right? Because when you're working with Bash, you use the head, right? Use tail, right? This is the same. So head will allow you to just take a peek at the first couple of records. Tail will allow you to take a peek at the last couple of records. Might be useful in some instances where you're uncertain about the structure of the data you're working with. But also, you will find yourself wanting to revisit the structure of the data frame. So you just want to take a look at the columns associated with the data frame, right? You can run the column command. Observe. So if I want to, I know that this has 61 observations, but I can run head. By default, it shows you just 5 rows. You can specify that you just want to see 1 row, right? I'll see just 1 row, the top row. I can run tail, right? And just look at the last record, right? The last record. I can say I just want to see the last 2 records, right? I want to see the first 2 records, right? I want to see the first 10 records, right? Well, I have this complex data set. I want to see the structure, columns, right? It shows you, right? It shows you the columns associated with your data frame, essentially. Very, very useful, right? When you're working with complex data. This is by no means an example of a complex data set. There's nothing complex about this. I mean, this thing only has, what type is this? This thing only has, I don't know what type this is. Index. Can we convert this into a list? I don't know. Any thoughts, by the way? Just talking here. Let me just check it out. It's not complex. It only has 27 columns, right? It's not complex at all. Probably simple, I guess. I don't know. Any thoughts so far? I'm going to pause here just to find out if people have random thoughts about Pandas, or you want to see clarification? I was hoping we were going to start our discussion on Crisp DM, but we can start next week, that's fine. No. All right. So, but there's more, right? There's a couple of other things that you might find useful. I think I already showcased an example of if you're one of those people who feels uncomfortable, you don't want to invest time in Pandas, and you've developed your own, you've invested so much time in using Excel. Maybe you've been using Excel for the last 10 years, maybe 5 years. I've been using Excel since 2007 myself. It's a long time, or spreadsheet applications rather. So sometimes I prefer to do things in Excel actually. As funny as it may sound. For me to be able to do that, I can export data from a Pandas data frame to Excel or to CSV, right? So there are functions that allow you to do that. Best way of doing this is so you can import your Pandas, and you can check out as PD. You want to check out pd.to. This is weird. I thought I had it's supposed to be a data frame. Actually, it's not Pandas. So I wonder if I can. I wanted to. You know what I wanted to do? I wanted to import this large data set, but my machine will hang, and I'll have to switch off this thing. This is almost a gig of data. But what I can do is I can say. I want to showcase this. So say import Pandas as PD. And then I'll say var CSC 5741 is equal to pandas.read PD, sorry, not Pandas, PD.read CSV. And by default, I always, my CSV file always pipe separated. I have run into problems where I'm working with data where there are pipe symbols, by the way. It can be very frustrating sometimes. But so if I wanted to export this, right, I can just run this to CSV is there, right? I can send it to CSV. So essentially what you're doing is you're writing data to a file, right? A couple of other interesting things that you might want to use is, a couple of other interesting things you might want to do is maybe rename. I rename columns a lot, right? Maybe you're working with a sort of data set where, and you've seen this before, right? Especially for novice users, they'll name, you're naming columns like it says student student space ID UNZA or something, right? I hate this sometimes. So what I have to do is I have to rename these so that it turns out for me, working with columns that are concatenated into one word is much, much better than having column names where you have spaces and weird characters. For you to change the column name, you can use the rename function, right? And then just pass it a dictionary or something. Sometimes you will want to aggregate data. You have access to pivot function, right? So I can say this dot pivot, right? I can pivot this information. I can group this information, right? Let's see if I can showcase an example of grouping information. Maybe we can group by, I don't think that there's an easier way of grouping by maybe type. Is there a way of type be? Yeah, type maybe unique. Type maybe, I guess, I don't know. Yeah, type would be a nice way of grouping because we have different types, others, thesis, article, book. Type is good. So what we could do here is we could say this dot group by type. So instead of doing some of the things I was showcasing in that example when we were grouping grades, trying to plot grades, I can use group by, right? So I say group by type or something, right? And then I could say I want to view, I think I can I run count here? Yep, I can run count, right? I can run count. And these are the same, obviously, so it's a bit dumb here. But you notice that this is quite useful, right? Because, and I think this is a great example that I should showcase here to showcase the real power of Pandas. I'm going back to Jupyter Notebook so that we appreciate this, right? Imagine you wanted to graph this information, right? So you have, just going to do that. You have, this is weird, it's not, I think it's 2 or something in here. No, it's in a different folder, sorry about that. All right. I didn't want to restart this, but I'm just going to move this to, sorry about that. And I want to go to lecture series number 2 on scripts. Excellent. So this should be able to work now. So, so I want to, let's say we wanted to group this information, right? Instead of going through the tedious process we went through, we're looping through things, and what we could do, right? And we use head here to take a peek at our structure. The structure of our data is like this, but all we could do is we could say, because we want to, let's say, group type, right? And we know that type has these unique items here. What we could do is we could say, we're going to aggregate this information, like so, right?
On Friday.
So, and then you say group by, we could say type here, right? And then you get to choose here what you want to group this by. And so I'm just going to say, because it's the same really, it doesn't matter, it's the same type, everything is going to be the same. I'll just group this by identifier or something, right? And then I'll count this like so. So that I have this sort of data set here, and I can actually chain commands here and be able to just say, well, I want to, I guess, pi or something. Can I plot a pie chart? No. Dot plot. I think it's plot or something. Plot kind, should be kind is equal to pi or something. I don't know if this will work. I hope it does work, but there we go. So you can actually, instead of doing things like in the Pythonic way where you have different subtasks that you come up with, what you can do is you can chain commands, right?
On sleep, the stomach is spinning.
Yeah, this is a pi and this is, I guess, bar H or something, horizontal bar plot.
But Misha,
this makes sense.
you know that I'm in class.
You notice that this data set that we have here has a lot more thesis than these other things, right? Few articles, few books, no software, a couple of technical reports, which is pretty, it's expected, I guess, I don't know. These are dissertations, I suppose. So we can plot bars and all these different things here. But all this is possible in essence because you can aggregate information, right? So a couple of useful things to work with in Pandas here. Do you think, just wanted to find out here, do you think we can pause for a little while and try out something as like an exercise? There should be an exercise, maybe, or before the exercise, maybe we can start with this exercise. Do you think you can, or would you rather work through this exercise yourselves? I'm looking at the time here. Do you want to try out the data set that I just showcased? If you can just try and read the CSV file, and can we have a volunteer maybe just try and run these few commands? I'll walk you through the commands if you want. How to read data and how to run these functions I was talking about, like head, tail, columns. Any takers or something? Is there anyone who has managed to download this data set here that I share? This data set? So get link. Or is there someone who is willing to download that, and then we try and use their notebook? I mean, it's become a bit monotonous with me just ranting and raving here. Maybe we can have someone just a volunteer just share their screen, and then I'll walk you through that. Any takers? Someone who has their notebook open or something? None. Maybe we are all using phones, right? But I just showcased how you can actually use your phone to install these interesting packages, right? Oh, this thing failed. Oh my goodness, failed. I'm using a lot. I don't know what happened there. That's very sad. I don't know if I had to use sudo here, but that's very sad. It failed. Command out of exit. That's very depressing. That's fine. Any takers? I guess I could probably install Pandas maybe. I don't know. Any takers or something? No one wants to volunteer. Okay, maybe we can then continue. Since it's becoming a bit monotonous talking about this, but we're on track to finishing this. I guess it's fine. Have you managed to download the data set though? No.
Doc, I downloaded.
Yes.
I downloaded that the import pandas in Jupyter Notebook is not working as expected. It's giving me errors.
Okay.
So I'm just trying to get.
But you want to at one time? I do encourage you to work through the notebook. Actually, it will be helpful. So you might think that the pressing the play button in Jupyter Notebook or something would be it's not going to be helpful. But it turns out this is done. I guess it can be helpful actually. It can be helpful rather than just. I think a session like this is not going to be that helpful anyway. So I thought maybe it'd be nice before we transition into scikit-learn, I guess something else I wanted to just quickly chat about is I included this in the notebook because I think Derek had asked if it would be possible to put information from database or something. I have a few examples, right? Now I don't want us to waste time and go through the specifics of how you do this, but there are clearly labeled steps on how you read data from some of the most commonly used databases. I started off with SQLite, and one of the reasons why I'm using these particular databases, both relational and Nosql databases, by the way, is because I'm also sharing data that you can use, right? So if you're interested in accessing data in a MySQL, right? From a MySQL data set, this is an example. There we go. So I have, so not in MySQL, an SQLite data set, which is the case here. If you notice, I have access to an SQLite data set, right? So I'll say SQLite 3, I guess. I don't know if it's 3. I don't know if this is a client here. But so I can how do I check? Does anyone remember? Has anyone worked extensively with SQLite? I'm forgetting I guess it's schema or something. I can check the schema of this. I don't know if this is, but there we go. So the schema of the SQLite database that I'm going to share with you is like this, right? And you notice that I can run really, this is not based on ANSI standards, so obviously I can check the count, right, from ETDs. And I see that I have 3,541 records in this in this table ETDs, right? So this database is quite simple. It only has one table, right? Something else you might want to do is look at the type we're talking about, right? Not count here, just say type. These are the types we have. We can, I don't know if it has distinct here or unique. Is it unique or distinct? Right, so these are the things we're talking about, we're plotting. So you see that we have access to this SQLite database. For you to pull information from a relational database management system like SQLite, one of the very first things you need to do is you want to install the library that's going to enable you gain access to that database, right? Once you do that, once you install the library, which there's a pip command here, right? You can. I'm sure there's maybe different ways of doing this depending on the type of operating system that you're using. Once you do that, the usual step is once that is successful, is you have to import the package, right? SQLite3 in this case. Once you import the package, you and maybe we can walk through this actually step by step. You install this, right? This won't work because I've already installed this, right? Well, it won't give us anything meaningful here. You import the SQLite3 package or library, and then you establish a connection. This is not to MongoDB, this is to SQLite, right? You establish a connect, you connect to the database. In this case, my database, the database name you're going to have access to, which I've shared, is dspace.sqlite, right? So essentially, it's this file here. Very small file, it's just 11 megabytes because we have about 3,000 records, right? 3,500 records or something. Once you do that, then this is where it gets really interesting. For you to create a Pandas data frame, you just issue, there's a Pandas, there's a read_SQL query function, if you remember this, when I was showcasing this. I don't know if people remember, when I said import Pandas as PD, I said there was a PD.read. This method is what we're taking advantage of. Read SQL_query. So you can issue an SQL query, as you normally would when you're extracting data from a database. This is quite useful really because the average person who works in IT has interacted with a relational database management system before. And so the thinking here is that you're working with something that is that is intuitive, right? You can run SQL queries like so. So in this case, I'm saying I want to create a Pandas data frame that is going to extract everything from this table, everything, right? And I've established this connection. Everything from the table ETDs. Once I run this, you will notice that what I have access to, this variable here, is going to be a Pandas data frame. This Pandas data frame is essentially composed of the fields that I was showcasing here when I was interacting with SQLite, if you remember this command here, right? These fields here that are part of this schema, these are the same fields that I have access to in my Pandas data frame. Everything is done for you automatically. You'll notice that the table columns are the ones that are going to be the columns associated with your Pandas data frame, exactly as they would, right? And so if we run our command here to try and check how many records we have here from ETDs, this 3541 here, 3,541 observations, is the same value we're going to get if we just check the length of this data frame, right? Length built-in function, right? 3,541. These are the same records, right? And really, I mean, you could pretty much run the same functions here, like head to. Now, another thing about this head function, and this is like the limit function in SQL, right? I don't know if this is here, limit 1 or something. I don't know if this works, but maybe not. I don't know if this works here. Yeah, it does. Right? So this is how you do it, and you essentially start performing the same operations specific to a Pandas data frame. Right? So you can run iloc and all the fancy things, right, that you have access to. Things like some of the things that I haven't spoken about that will pop up a lot very, very soon. Some of the things that what are some of the random examples? I like transposing data as well. So notice if I say I want to view the first 2 records, you notice how, because this thing has a lot of columns, I have to scroll to the right. Well, you can transpose, right? You can transpose this like you would transpose in Excel, I guess. You can transpose this so that you view this information in a manner that's more user-friendly or something. So I've just flipped them. I've flipped them over so that my columns are now rows and my rows have become columns or something, right? So this is how you do it in SQL Lead. Well, it's same approach for, I guess, for NoSQL databases. So if you are one of those people who works a lot with your modern day databases, which are NoSQL databases like MongoDB or CouchDB or something, what you could do, right, is you could say, I hope I have this Zambian watchdog thing. You could say, I guess, I have a MongoDB, I think I have Mongo installed here. So you could, yeah, I think so. There we go. So you could say, so this is how you'd interact with MongoDB, right? Where you're saying use, I guess we use this or something. Show collections. Page post db.page post.find or something. I mean, so this is how you would kind of interact with your typical MongoDB database, right? I mean, you can filter records and whatnot. But the question is, I mean, what if you wanted to import this information into a Pandas data frame, right? Because I don't know about you, but working with a JSON output like this is a bit cumbersome, right? You rarely do this. In fact, people rarely analyze data in JSON format. Usually, when you understand the structure of the data, which is in JSON format like this, for instance, all you do is you write your code or something, and then you're looping through and performing whatever operation. But what if you want to analyze this data? Well, you can install PyMongo, for instance, right? So you install a library that's going to enable you interact with MongoDB. So in this case, I encourage you to use PyMongo. And then in the event that you are working with, the example in here, by the way, I'm not sharing the original source of the example associated with MongoDB. I am not sharing the CSV file, because that will mean you need to install MongoDB on your machine. Rather, what I'm doing is I've opened up, I've created a MongoDB Atlas database. I've created a MongoDB database using MongoDB Atlas, right? So it's a cloud version of MongoDB essentially. So you should be, for you to be able to interact with MongoDB Atlas, you need to install DNS Python, right? For this to work, you just need to make sure you install this library there. And then the next step is you want to import PyMongo, right? So I've imported PyMongo here. And then what I do is once I import PyMongo, I establish a connection to MongoDB. So the cluster that, the MongoDB Atlas cluster where you will find that information, by the way, is this. So just run this code here, it should be able to work, right? So I establish a connection, and then I will have access to this document here, or this database rather, right? And then I can then access a specific collection. In this case, I'm interested in this page post, right? So you notice that I can pull information that I want. It's going to take a bit of time because it's establishing a connection to MongoDB, right, by the internet or something. But in essence, I mean, we don't want to go through the gory details of trying to explain the structure of this information. This was extracted from Facebook, right? So you'll notice that your Facebook post will have an ID. The source here is Zambian Watchdog. These posts are from Zambian Watchdog. The date when the post was posted. Oh, I decided to use this as an example. I don't know if you remember when Chipomusan was sent to prison, drug dealing here, right? We don't know if he's still there, but anyway, the key thing here is that once you have this data, you can interact with it, right? You can interact with it because it's now going to be imported as you can now import it into a Pandas data frame and be able to work with this. Quite useful, very, very useful stuff here. But anyway, there's more out there, right? You can read, you can import raw JSON input, right? So if you have a JSON file on your file system, for instance, you can read that into into MongoDB, sorry, into a Pandas data frame, right? All you do is you say import Pandas as PD, and then you have pd.readJSON, read JSON, right? Some interesting things that you'll be able to do as well is, in essence, you can actually read any sort of structured data into a Pandas data frame, right? You can read CSV file, which I've been using these examples a lot. The only things you want to pay particular attention to is the separator that you're using, right? Sometimes your CSV files will use a comma by default. Some of them will use semicolons. I prefer to use a pipe symbol myself. It's different. Some data that I work with, I have used very weird separators, right? Because of the structure of data I'm working with. And maybe I can use this as an example. Ooh. If I use this as an example, I guess it's a fancy bad example. It's I wonder where that is. I wanted to showcase an example where I have a CSV file that that actually makes use of I don't know if maybe some data. I thought I had that large file that I had been working with. Maybe not. That's fine. But anyway, so you can read the CSV file. You can also read HTML input data, right? Very, very useful. If you're scraping for data, for instance, this becomes handy. Sometimes you might find yourself working with HTML input that is structured. I like using the Zambia Wikipedia page as an example here. So if you go to this Wikipedia, your Wikipedia page is structured, right? It's HTML, but there's a predefined structure. So all you do is you import pandas and then you use the read underbar HTML. So in this case, you notice that we are reading the Zambia Wikipedia page. And then using this, we have access to all the different aspects of the Wikipedia page, right? I don't know if you understand this, but if you read Wikipedia, you remember that Zambia Wiki, you remember that your Wikipedia page is structured in a certain way, right? Right. So this is what we are reading here. Yeah. So these things here, the content and the coat of arms and all these different things. So if you were wanting to analyze Wikipedia data, for instance, you read HTML would be quite useful, right? And be able to do your analysis. Of course, in this case, maybe you'd want to analyze country pages using pandas, right? You know, so if we were to look at, let's say, wanted to analyze languages, right? This is ILOC number 8. Instead of this, we'll just say, I'll say ILOC and then 8. This is actually, is it index? It's not index 8 here. Let's see if we can get, I want to get, I hope this is the one, ILOC. This is not a list, actually. I've converted it in something else here. I'm putting the wrong things here, right? I'm just going to go back here. I'm putting the wrong things. What I'm going to do is I'm going to say, I'm just going to get, I think this is returning, sorry about that. It's returning, it's not a data frame. This is weird. I thought this was a data frame though. It has to be a data frame, is it? I don't know where the list is going. I'm going to get the original line number 7, which is, I'm going to get line number 7, which is, run this. I want to see if we can get some information that we can easily relate to on Wikipedia, right? So let me just check the type here. Okay, this is the list. Okay, what if we get list 0? Okay, so we get a list, but then within a list is where you have data frames, right? So these are all lists. So we can get a list that is the list item associated with recognized regional languages, right? Which is index 6. So index 6. And because this is a data frame, we'll just say head and then just see 2. There we go, right? This is exactly what we wanted. Beautiful. So I mean, this is how you're reading HTML data essentially, right? So structured data. So depending on what sort of analysis you are doing here, you could pull out whatever series you want from here, right? Interesting stuff. I also have I don't know if I have examples on how to work with JSON files. Yep, there we go. There's an example here as well. I'm just gonna pause here and just find out if people have any questions really. I'll leave it up to you to just, please, just at the very least, just try and familiarize yourself with how to read CSV data. Because most of the examples going forward are going to be reading data from CSV. The approach I've taken to simplify things is, irrespective of the source, I export data from that source into CSV and then import the CSV into its Pandas data frame, essentially. So I do encourage you to just familiarize yourself with how to import data, CSV data, right? So that these things don't appear foreign going forward, essentially. I don't know if there are any thoughts or comments. I think this installation. Any thoughts or comments about this?
Dr. Perry?
Yes, hi.
Yes.
Light on is fine.
I think
yes,
I missed where, because I'm seeing the way your presentation is coming out when you're reading the file.
Yes.
Yeah, the CSV or the Excel file.
Yeah.
It seems to be coming like all the tables are coming out neat. For mine, it's like it's reading all the data but not showing everything.
Are you able to?
There's something I missed, maybe.
Are you able to share your screen? Maybe.
Yes, no problem.
Yeah, I'll unshare this. This would be a nice way of wrapping up. At least we have somebody who is able to share. What you'll notice, right, is that my notebooks will have certain configuration details up on top to make the output more aesthetically pleasing. I normally, there's certain configuration details associated with Pandas that I use. But let's look at you can share your screen. Let's look at what you have. And as you're sharing, maybe, Derek, I don't know if you have a question, maybe you can ask away and then we'll...
Are you able to see my screen?
Yes.
Yes, I think this is what I mean. I was looking at the difference in how when you're reading and how the files are coming out. But I don't know if what I could have missed. I may have just.
It's so yeah, it's the code that and the reason why mine looks like that is I tend to export. I don't know if people have gotten to a stage where you've accessed that PDF export of the notebook. Huh? So the reason why mine looks different is because I also export stuff to PDF. If you want it to look that way, for whatever reason, there's a cell. There's a cell that I almost always include that says, it says general notebook configuration. Now, under general notebook configuration, you want to set options like, maybe we can try and check it out right now, right? I could have missed out a few things here, but I've pasted something in the chat. Do you want to paste that stuff at the beginning of your notebook?
Okay.
Yeah, just copy that, the pd.set option, and then just try and see if you can run that. And then let's run one of the cells that has that has that is going to output a Pandas data frame, like the one you have in 24, I guess. Nothing still, right?
Still coming out the same. Or is this supposed to be?
Oh, no. So the reason why is, can you go back to that cell, 20, the cell, and just instead of print, no, the previous one you had, instead of print data frame, don't print it out. Just no, the one you had before where you have a data frame, the one you ran before.
Oh, okay.
Yes. Instead of that line that says print, so remove the print df. Just run df.
I remove this.
Yeah, instead of print df, just replace that with just df. Everything is just df.
Okay.
No, that maybe that will work or something. I don't know. I hope so.
Just like this.
Yeah, just run it. Let's see. Yeah, there you go. Is this what you meant, right?
Yes.
Yeah. So you don't have to. Printing is like you're making it redundant. You have to print it because it renders it for you.
Okay.
In fact, if you check the result of the print, it's probably some different data type. So there you go. So forget about the part where I said the notebook configuration, but it turns out that the configurations might be useful. There are some times, right, when you're working with a small data set, you want to show everything. You don't want those ellipses. Those are the options that you can set, the ones I just pasted.
Okay.
Yeah. Any other thoughts? Yeah. I don't know if my approximation techniques here are quite bad here. I was actually thinking that we were going to finish off this part and then transition to the crisp DM model. But I think this is good because by the time we are looking at the different phases, we can now sneak in some specific examples, right, on how we do certain things, like how we transform data, for instance, and how we get to pre-process data. Any other thoughts? There's the last part where we're talking about scikit-learn. I just wanted to just maybe, Francis, if you can unshare, and then I will share my screen again. When it comes to scikit-learn, I guess it's just, you just want to make sure that you install scikit-learn, right? So that when we get to a stage where we start looking at model implementation extensively, you would already have had installed the library, the scikit-learn library. This is where we get we gain access to the estimators that we're going to be using and really ways of transforming data, right? So if you have text data, how do you get to transform it into a form that the estimators are going to understand? If you want to transform categorical data into a form that the estimator expects, how do you use things like one-hot encoding, for instance, right? So you need scikit-learn for that. And scikit-learn, as with many Python libraries, is quite easy to install. All you do is you run pip install sklearn, and then you will have access to everything that you need, right? So this screen is just showing you an example of using pip. Now, again, I'm not sure, those of you that have installed Anaconda, I don't know if you can already gain access to scikit-learn, right? So it's sklearn, import sklearn. I don't know if you can import sklearn with Anaconda. I think it should be the case. I don't use Anaconda myself. I prefer to install these packages or libraries individually rather than as part of one package. But you will see us importing a lot of interesting things here, right? And that's why getting a sense of what's accessible to you in sklearn is like that, right? There are specific modules that we're going to be importing from here. But yeah, any sklearn.externals. External. Let's try dir here. sklearn. I'm trying to think of help. sklearn. I'm trying to think of a particular package that would need that good package, feature extraction, I guess, or feature selection, maybe. Oh, there we go. Datasets is a good example, right? So right within sklearn, right? So you can say from sklearn, you can say import datasets, right? And then what you notice is that you have access to some really interesting toy datasets, right? You have access to the popular datasets that you'll find in tutorials that you're reading online, by the way. So things like datasets.load, the so-called Boston housing dataset, right? The breast cancer dataset, right? They're small little datasets, but they are quite used. The wine dataset, right? The digit dataset is used quite often for problems or tutorials that look at how you get to work with image datasets. So in essence, I mean, the only thing you need to do really is just to make sure that you install sklearn, and then we'll get to a stage where we get to play around with sklearn. I'm just going to pause here. I'm looking at the time. It's almost 11 past. I'm going to pause and just find out if there are any specific questions or if people have comments about what we've covered in lecture series number 2. We rarely, to be frank with you, we rarely have any form of assessment or assignments associated with this, because the reason why we have this lecture series is to ensure that we get to a stage where we are able to understand the things we're going to be doing once we start our discussion with the data mining phases. It's a means to an end, essentially. Well, I suppose you get to use it in the mini projects that will be circulated very, very soon, by the way. And also, as you're thinking about questions, I'd mentioned that we'll hopefully have a set of people that have committed to giving talks. Not yet. I think hopefully we should have a comprehensive set of invited speakers by next week, I believe. But any thoughts or comments about this particular lecture series, or parts that you think were a bit unclear? Please, if you need help with anything as you're getting started, reach out to me and then I can point you in the right direction. If there's stuff that is not going to make sense, you want to reach out to me before we actually start making use of this. All right. I don't know if I start this. Okay, if there are no questions, then I suppose we'll call it a night. I will see you next week when we start our discussion of lecture series number 3, which is a crisp DM. If I haven't uploaded the slide deck, I will upload it for lecture series number 3, so that those of you that want to go through it can already start going through it. Thanks and good night.
Thank you.